let's take a look at a problem like this. 5/8 minus 1/3. Well, now our denominators are not the same. Our denominators are not the same. So we're going to have to rename these fractions in a higher name. So we're looking for, we need a number that 8 will go into that number evenly, and 3 will go into that same number evenly. Well, if 8 has to go into the number has to be 8 or bigger. So let's start with 8. Now we know 8 will go into 8 evenly, obviously one time, but 3 will not go into 8 evenly. So then we say, well, okay, what's the next biggest number that 8 can go into evenly? Well, 8 is 16, so 16 would be the next number that 8 can go into evenly. And 8 would go into 16 two times, but 3 cannot go into 16 evenly, so we can't use that. So then we have to say, okay, it's not 16. What's the next number above 16 that 8 will go into evenly? Well, 8, 16, 17, 18, 19, 20, 22, 24. So 24 is the number. Okay, so then we're going to have to raise both of these fractions to a higher name with a denominator of 24. And the way we do that, as you know, is you say 8 times what number gives me 24? Well, 8 times 3 will give me 24. So then I multiply 5 times 3. 5 times 3 is 15. 3 times what number will give me 24? Well, 3 times 8 will give me 24. Therefore, I multiply 1 times 8. 1 times 8 will give me 8. Now I have renamed 5/8 to 15/24, and I have renamed 1/3 to 8/24. Now the denominators are the same, so now I can subtract. 15 minus 8, 15 take away 8, give me 7. 7/24. This is a proper fraction, and it is in its lowest name. It is in its lowest name. This is an odd number, that's an even number. So that fraction is in its lowest name, so that's our answer, 7/24. So, again, let me get rid of all of this scribble that I have here so it's not too confusing. But, pardon me, we had to take the fraction 5/8 and the fraction 1/3, and we had to rename them. We had to rename them in a higher name so that we could get the denominators to be the same. Okay, well, we're going to do some practice with some problems like this, and we'll continue on. Okay, so the problem now is 5/8 minus 1/4. And again, the denominators are different. So we're going to have to rename either one or both of these fractions. So we need a number that 8 goes into evenly and 4 goes into the same number evenly. Since 8 has to go into it evenly, let's start with 8. Obviously, 8 goes into 8 evenly. And 4 goes into 8 evenly. So we can use 8. So this time we'd only have to rename one. We don't have to rename this one because it's already an 8. So we have to rename this fraction in terms of eighths. Well, 4 times 2 will give me 8. So then 1 times 2 gives me 2. Now I've renamed this fraction in terms of eighths so the denominators are the same. Now I can say 5 take away 2 gives me 3 eighths. So 5/8 take away 2/8 is 3/8. This is a proper fraction, so I don't have to change it, and that's an odd number, that's an even number. This is in its lowest name. So that's our answer. Good. Well, I'm going to put up several problems for you. So I'll be back in a second. Okay, here's 2 practice problems for you. You have 5/6 minus 1/3. And in the second problem, 5/6 minus 3/5. put the DVD on pause and in your notebook, work the problems, then turn the DVD back on again and I'll go through the explanation and we'll see how you did. Well, okay, let's take a look here. We have 5/6 and 1/3, so the denominators are not the same. So we're going to have to rename one or two of these fractions. We have to find a number that 6 will go into evenly, and also the same number, 3, has to go into evenly. And we know that if 6 has to go into the number, then we should at least start with 6, because the number can't be less than 6. We know that 6 goes into 6 evenly, and 3 goes into 6 evenly. So we can use 6 then as our denominator. We don't have to raise this fraction to a higher name because it's already in sixths. So we just have 5/6. Now here, we say 3 times what number will give me 6? Well, 3 times 2 will give me 6. So now we multiply 1. 1 times 2 gives me 2. Now I have renamed 1/3 to a higher to the fraction with a higher name, which is 2/6. Now I can subtract because our denominators are 6. 5 take away 2 gives me 3/6. Now here, even though this is an odd number and this is an even number, this fraction is not in its lowest name, because 3 can be divided into 3 one time and 3 can go into 6 2 times. So we have to reduce 3/6 to 1/2, and that's our answer. Let's take a look at the second problem. 5/6 and 3/5. Well, the denominators are different, so we may have to rename one or maybe both of these fractions. So we're looking for a number that 6 will go into evenly, 6 will go into it, and 5 will go into it. Well, as you know, we'll start with 6. Well, 6 goes into itself evenly, but 5 does not. So what's the next number that 6 can go into evenly? Well, the next number is 12. 6 can go into 12 2 times, but 5 does not go into 12 evenly. Well, the next number after 12 that 6 can go into, 12, is 18. 6 goes into 18 3 times, but 5 does not go evenly into 18. So we can't use 18. Well, then we have to go the next number bigger that 6 will go into evenly. So it's not 18, so 18 and 6 would be 24. 6 will go into 24 4 times, but 5 does not go evenly into 24. So then we have to go the next number above 24, and that is 30. And 6 goes into 30 evenly, and 5 goes into 30 evenly, so we can use 30. So we're going to have to raise both of these fractions to their higher name with denominators of 30. 6 times what number gives me 30? Well, 6 times 5 gives me 30, so then I'll do 5 times 5 gives me 25. So I have renamed 5/6 to its higher name, 25/30. Now we'll do the same thing here. 5 goes in. 5 times what number gives me 30? Well, 5 times 6 gives me 30. So then I have to multiply this by 6. 3 times 6 gives me 18. I have renamed 3/5 into 18/30. Now I can subtract because the denominators are the same. 25 minus 18 gives me 7. And my answer is 7/30. This is a proper fraction, so it doesn't have to be changed, and this fraction is in its lowest name, so that's the answer. Excellent. Well, let's take this one. Here we have two mixed numbers, and the denominators are different. And you know, when we have mixed numbers, we don't deal with the whole number first, we deal with the fraction first. So let's deal with the fraction. We're going to have to rename one or two of these. to a higher name, we need a number that 7 will go into evenly, and the same number 3 has to go into evenly. And you know, you've heard me say it a million times, if 7 has to go into the number evenly, let's start with 7, because the number has to be 7 or more. Well, obviously 7 goes into 7 one time. 3 does not go into 7 evenly, so we can't use 7. Well, then what's the next number, the next biggest number that 7 goes into evenly? Well, we know 7 and 7 is 14. So 7 will go into 14 2 times, but 3 will not go into 14 evenly. Well, if it's not 14, what's the next biggest number that 7 goes into evenly? It would be 14 plus 7, so that would be 21. 7 goes into 21 3 times, and 3 goes into 21. So 21 is the number we use. Okay, now we're going to raise 2/3 to a fraction of a higher name with a denominator of 21, and the way we do that is 3 times what number gives me 21? 3 times 7 gives me 21, so then I have to multiply this by 7. 2 times 7 is 14. So I've renamed 2/3 to 14 21s. Now I have to rename 4 7s. 7 times what number gives me 21? Well, 7 times 3 gives me 21. So then I multiply 4 times 3. 4 times 3 is 12. Now I've renamed both fractions, and I have the denominators the same, they're 21s. So I can subtract 14, take away 12 is 2 21s. That's a proper fraction, and it's in its lowest name, so I just leave it. So now I can deal with the whole number. Now I can subtract 5, take away 3 is 2, and that's the answer. So whether you're working with mixed numbers or fractions, the process is exactly the same. So now we're going to go to one. So if you want to stop now, you can feel free to stop now, but if you want to continue on, there's one other skill that we have to learn in the subtraction of fractions.